Hi guys, it's Mr. Kreisler, and today we're going to be talking about the dots method for factoring. And the dots method stands for a difference of two squares, where the difference means we're seeing subtraction, two meaning there's two terms, so two, and then it's like when we're talking about terms, and squares meaning perfect squares, such as the square root of 49 equals 7, and the square root of x squared equals x. So let's move on to our first example. X squared minus 100. So first, D, difference. Are these two terms being subtracted? Yes, there's an x squared and minus 100. So now, are they perfect squares? Well, the trick is with exponents. So perfect square exponents are always even. So that means x squared, x to the fourth, x to the sixth, x to the eighth, blah, blah, blah. Anything with an even exponent are a perfect square. Now, as far as knowing the numbers, well, you got to kind of memorize some of these. Square root of 4 is 2. Square root of 25 is 5. Square root of 36 is 6. And the special case one, the square root of 1 is just 1. That one's just a special one. So when a perfect square exponents are even, all we're doing is dividing that number by 2. So the square root of x squared would just be x to the first, which is just an x. Square root of 100 is 10. So we know we have two perfect squares here, so this works. Whenever you recognize that you have dots or a difference of two squares, it's always set up by your double bubble or two parentheses and your positive and negative. Now, the order here does matter. Since x squared is first, we're going to try to find the square root of this one, which is just x, and it goes in the first part of the bubble. Second part of the bubble, well, that's the second term. So square root of 100 is 10. That's it. That's your answer. Now, some of you might be asking, what if I do this, Mr. Kreisler? What if I put the negative first? And when it comes to the rules of multiplication, it does not matter if the positive or negative goes first when multiplying, because negative 2 times 3 is negative 6. And negative 3, negative. And positive 3 times negative 2 is still negative 6. So this works as well. Either case is correct. All right, pause the video if you need to look over it. Otherwise, let's move on to another example. All right, so let's do this one. X to the fourth minus 1. We got to remember our rules. Are there two terms? Yes. Are they being subtracted? Yes. Is the exponent even? Also yes. Is the coefficient or constant, depending on the situation, a perfect square? Yes. And square root of 1 is 1. That's one of those special cases. What will be the square root of 4 of x to the fourth? Well, simply, you just take the exponent and you divide it by 2. So what's 4 divided by 2? That's 2. So this actually becomes x squared. So we're going to write it out. Do your double bubble, positive, negative, and keep it proper in the proper order. So x squared goes first, then the 1 goes second. And that's really it. Now, as an extra step, and this you'll see these in the more advanced cases, so I'm just going to show it to you guys quickly. You want to make sure that both factors are perfect factors. You can't really do much with x squared plus 1, or nothing easily, but we're talking about dots here, so we're dealing with x squared minus 1. So look what we got here. Even exponent, and we can always take the square root of 1. So we can actually break this one down into another double bubble. plus minus square root of x squared becomes x. Square root of 1, we already said is 1. So your real final answer would actually be this one if we were just talking about dots. But this is acceptable answer. I just want to introduce you to this guy, give this one special. And if you're going on to college and other things, you may see it. All right, let's do one more. Now we have x to the 6 minus 9. Do we have two terms? Yes. Are they being subtracted? Yes. Is the exponent even? Also yes. So what is 6 divided by 2? 3. So the square root of x to 6 would be x to the 3rd. Is 9 a perfect square? Yes, the square root of 9 is actually 3. In this case, they both the exponent and the coefficient end up being 3. That's just pure coincidence. All right, so we know this is dots. So first step of dots is always set up your double bubble, positive, negative. So what goes first? Well, we have the variable first in this case. And the square root of this variable of x to 6 is x to the 3rd. So let's put that first in both of the parentheses. And then the square root of 9 we said is 3, and that goes next in the parentheses. And that's it. There's your answer to dots. One last one. This one is when they try to throw multiple variables at you and just try to throw you for a loop. So they give you something like this: 16 x squared y squared minus 25 z squared. Doesn't matter what the variables are. All that matters is the exponent. Do we have two terms being subtracted? Yes. This is your first term. This is your second term. So automatically set up your double bubble. Positive, negative. Let's work with the first one right here. How are we going to break this down? Let's see. The square root of 16 is 4. The square root of x squared is x. Remember, you're just dividing the exponent by 2. 2 divided by 2 is 1. Square root of y squared divided by the square root of that is, so 2 divided by 2 is once again y. So this first one would just be 4xy. So that one is the one that's going first here. Now let's take a look at the second term. 25z squared. So what's the square root of 25? That's just 5. And like I said, if you want to take the square root of a variable, if it's even, super easy. Divide the even exponent by 2, and 2 divided by 2 is 1. So we have 5z. So 4x plus 4xy plus 5z, 4xy minus 5z. And that's our answer. Please ask any questions you have about this. Otherwise, pause the video, look at it, and that is factoring using the difference of two squares, also known as dots.